How do scale drawings and actual measurements represent proportional relationships? Think about this question during the lesson. The island in the blueprint is 6 inches long. What is the actual length of the island in the kitchen? A scale drawing is a model or drawing based on a ratio of dimensions for the model and the actual object it represents. A scale factor is the constant that is multiplied by the length of each side of a figure to produce an image that is the same shape as the original figure. Here is one way. Use a double number line to represent the scale drawing length and the actual length. The scale is 1 inch for the blueprint is equivalent to 1 5/10 feet for the actual kitchen. This means that as the number line for the blueprint increases by 1 inch, the number line for the actual kitchen increases by 1 5/10 feet. As shown by the number lines, what is the actual length of the island in the kitchen?
Select your answer.
The double number line shows that a length of 6 inches on the blueprint represents an actual length of 9 feet. Another way to solve the problem is to use a proportion to find the actual length, x, of the island. Use the scale to write the proportion. 1 inch on the blueprint equals 1 5/10 feet on the actual kitchen. Divide both sides of the equation by 1 inch to show the ratio 1 5/10 feet to 1 inch. This ratio will be the constant scale factor for all lengths in the drawing to the actual lengths. Write the scale factor on one side of the proportion. The other side is the ratio of x, the actual length of the island, to 6 inches, the length of the island in the blueprint. Make sure to write the ratio in the same order as the scale factor. Solve the equation by multiplying both sides by 6. The actual length of the island is 9 feet. Now you know that a scale drawing and actual dimensions are related using proportionality. What is the actual width, W, of the island if the width in the drawing is 2 5/10 inches?
So, according to the example, we have for the scale that 1 5 feet is equal to 1 inch. So that would be a 1. And so we need to find the width, the actual width, if it is 2 5/10. So the island width, the actual one is 2 5/5 inches on the drawing. So we need to find the actual length. So we're going to take the 2 5/10 and we're going to do the inverse of dividing, because W feet divided by 2 5/10 inches is the inverse is multiplying. So we're going to multiply 2 5/10 on both sides. So that's 2 5/10, 2 5/10. That's a 1, and that is a 2 5/10. So that cancels, and then we have the 1 5/10 times 2 5/10. That is 3 75/10 is equal to the actual width of that island. So the actual would be 3 75/100 feet.
What is the area in square yards of the deck represented by the scale drawing?
Select each length in the scale drawing to find the actual length. So step 1, find the actual length of the deck, L in the scale drawing. So we have the scale is 1 centimeter is equal to 2 yards. So we have the scale factor of 2 yards over 1 centimeter is for K. So that is what K equals. So that is 2. And then 16 is the length from here to here of the deck. 2 times 16 is 32. So the actual length is 32 yards. Then we have the step 2, which is the width. And we need to find the actual width. Again, K is the scale factor. 2 yards is equal to 1 centimeter. So that's 2 times the 8, which is the length from here to here. So 2 times 8 is 16. So the actual width, of the deck is 16 yards. And they're showing us here now step 3 is to find the area. 32 and 6 times 16 is equal to 512 yards squared. So now we know the area of the actual yard deck in the backyard.
Students are recreating the landscape drawing shown at the right for a mural. What is the area of the actual mural?
One way is to find the actual length and the actual width of the landscape. So we have 8 and 10 inches as the drawing or the mural. K, again, as we learned from the example, is the scale. So the scale used here is 4 feet is equal to 1 inch. So that's going to be 4. So 4 times 10, which is the length here. So 4 times 10 is 40. That's the actual length. And then the width is K times 8, so 4 times 8, and that's 32. And then 40 times 32 will give us the area of 1,280 square feet. Another way is to relate the scale factor K to the constant of proportionality between the areas. So the area of the original landscape is length times width, and the scale factor K is equal to 4. So the area of the mural is areas equal to K times L times K times W. So K, again, we know is 4. So 4 squared times 10 times 8. And then we have 16 times 10 times 8. And that's equal to 1,280. So that gives us the same answer, just a different way of doing it.
The scale drawing shown represents a circular playground with a scale factor of 1 inch equals 15 meters. What is the actual area of the playground? Give your answer in terms of pi.
We know the scale factor is 1 inch is equal to 15 meters. We also know that the formula for the area of a circle is pi times radius squared. So now we need to find the actual radius of the playground. So 5 inches times the scale factor of 15 meters is going to give us the actual radius of the playground. So 15 times 5 is 75. So 75 meters is the actual radius of the playground. And so we're going to multiply that by pi, and I'm going to use 3 1/4. I keep saying 1/4, 14 hundredths to give me my answer. And then let me just erase that real quick so that I can make this be inside my formula now. So that's squared. So first we got to do 75 squared. So 75 squared is 75 times 75. And then that equals 5,625. Now we're going to multiply that by 3 14 hundredths. And we get 17,625 663. And that's going to be an approximation because pi is not an exact. So it's going to be about, and I round it to the nearest ones place because it gave me a decimal, but I wanted a whole number. So it's 17,663 meters squared.